unit is all about quadratic equations. So remember, quadratic equations make that U-shaped parabola, or they could be flipped upside down, but they still have that curved shape to them. First, we are just going to be talking about how these equations are written and how we can identify specific parts. Okay? So it says that a quadratic function is a function that can be written in the form y is equal to ax squared plus bx plus c. Okay, so anytime we want to graph our quadratic, we're probably going to have it written like this, so we could type it in our calculator and graph it so we can see what it would actually look like. Right? Now, remember, these numbers here are just kind of like your slope in a linear equation. Right? It tells you how much up and over, or how much it's been moved up or down, things like that. Okay? While linear functions form a straight line, like we say, quadratics are going to make that U shape that we call a parabola. They want us to use this word bait here to fill in this picture. So they have all these arrows pointing at different parts of the picture. We're going to fill them in. Okay, so the first thing that they have is a vertex. So what do we think a vertex would be in one of these pictures? We think it, what were you going to say? The top. Very good. And this one did specifically say a vertex that's a maximum. Maximum means as big as you can get, right? So this point right here would be a vertex that is a maximum. Okay, so here's a vertex that's a maximum. So which one of these do you think is a vertex that's a minimum?
The one next to it.
Right, the one on the other figure. Very good. So the way we determine if it's a maximum or a minimum depends on which way our graph is facing. So if our vertex is up here at the top, it's a max. If it's down here at the bottom, it's a minimum. Okay? Our next term is axis of symmetry. Well, if you guys remember back in elementary grade school, they told you that symmetry meant you could fold it in half and everything would match up, right? So, which one of these things that it's pointing at do you think would be where we could fold it in half and the U shape would match up? Right. I could fold it along this dotted line here, and they should be exactly equal on both sides. Okay, so axis of symmetry is our dotted line. Okay? Alright, then we have x-intercept. Well, which ones of these could be x-intercepts? What is x-intercept?
Points that touch the x-axis.
Exactly, right. And they said this is the x-axis, right? They put a little x right there. So it's pointing at two places where it touches the x-axis. So both of these would be x-intercepts. Okay. All right, and then lastly, our y-intercept is where it crosses the y-axis. They said this was our y-axis, so this point touches that line. This must be our y-intercept. All right. Okay, so now that we know where all of these things are located, they're going to give us a picture of some function, some quadratic function down here, and we're going to label those exact points of those places. Okay? All right, so whenever we get down here, it says that the quadratic function x squared plus 2x minus 8 is the one they have graphed. They want to know where is the vertex. Well, according to where we labeled, is this vertex going to be a maximum or a minimum with the way this graph is facing? It's minimum, okay? And it should be this point right here. Well, where is that point? Oh, is it? Sorry about that. So if I count, it would be at -1, -9, okay? And like you guys said, this would be a minimum. Okay, so on the next one, where they ask, you guys already said it would be a minimum. Okay, next they want the axis of symmetry. Well, what did we say the axis of symmetry was?
The dark line they split it in half.
Right, goes right down the middle. Okay, so our dotted line where we could fold it in half would go right here, right? Okay, so if it's a vertical line, is that when we write x equals the number or y equals the number? X equals, right? Because if I move over here, I'm at a different x value. If I move over here, I'm at a different x value. I can move up and down, which is y. So the y value is not going to stay the same, but the x value will stay the same. So our vertical lines are x equals what? Where are we? Very good. Okay. All right, then we have our y-intercept. Y-intercept is where it touches the what? Y-axis. It looks like this may be cut off the very bottom of y'all's too, but that would be 1 point above the minimum, which would be at -8, right? So the y-intercept is at 0, -8. Okay, and then my x-intercepts, where are those at? So x-intercepts at the points -4, and we have another one at +2. Very good. Okay, then they ask about the domain and the range. So is domain my x or y values? X. Okay, so x goes left and right. Is this parabola ever going to stop going to the left? Is it ever going to stop going to the right? So what do we say when it goes both ways forever? Very good. Okay, the range. Is this thing ever going to stop going up? No, but does it go down forever? No, we said its lowest point was right here, right? So what's the y value at that point? -9. So it's going to have to be -9 or above, right? So remember, I'm going to write that as y has to be greater than or equal to that lowest point at -9. Okay? All right, and then last question, they ask, for what value of f of x does f of x equal -5? Okay? So I go to my graph, and I'm going to go to -5. -5 is right here, right? Okay. If I draw some line at -5, how many times did it cross my graph? 2 places, right? So when we have -5 as our y value, there's 2 possibilities for x, right? Can you guys see where those would be at on yours, or is it too far? Too far? Okay. All right, so we're at -5. That would be at -3 and at +1. Okay? Okay. All right, flip it over onto the back. We can see the top now, and we can see the y-axis and all that stuff, so we'll be okay. I think we can still fill it in. Okay, so on number 2, with this equation, it says where is the maximum point? Well, we can see that, right? The maximum point means the highest it goes. So that's there. Where is that on our coordinate plane? 125, and what would be the, oh, you can't see the bottom, that would be 4. So we would say that our x value is 4, and like you guys said, the y value is 125. Okay? My axis of symmetry or line of symmetry is where I can fold it in half, right? That would be the line I just drew in, is right down the middle. Okay, what was the x value at that point? 4. So our line of symmetry is at x equals 4. Okay, the y-intercept, that means where it touches the y-axis. Okay, here's my y-axis. Where does it intercept? Right in the middle of 40 and 50. Good. So at 0, 45. I guess y'all's is probably more zoomed in, so it probably looks really close. Okay. Then they ask for the x-intercept. So I know that y'all can't quite see the bottom, but we can see one x-intercept if you look up here at mine, and it's at 9, right? But mine also doesn't show where it would touch over here, but we know this graph keeps going over here, right? So there should be another x-intercept somewhere over here. Okay, well, we said that if we folded in half on this line, that everything would match up, right? Okay, how many places do I have to move this direction to get from the middle at 4 over here to 9? 5 places. Okay, so I had to move 5 places to the right to get here. That should mean the other one is 5 places that direction, right? Well, if I'm at 4 and I move 5 places to the left, where am I going to end up at? Very good. So there must be x-intercepts at -1, 0, and at 9, 0. Okay, for domain. Like we said, we can't see the ends of the graph, but we know this thing is never going to stop going to the left, and it's never going to stop going to the right, so our domain should be very good. Okay, now for my range, this is up and down. Is this thing ever going to stop going down? But does it go up forever? No, what was the highest we said it would go up? 125. So that means y has to be 125 or below. So I write that as y is less than or equal to 125. Okay? It says, what is the best estimate of the largest value of x for which this function equals 80? Okay, well, here's 80, right? I'm going to draw my line here. So how many times did it touch 80? Twice. But they said they want the largest. So which one of these is going to be the largest value? Right, which would be at 7. All right. Thank you. Okay. All right, we got one more, and on this one we're drawing our own picture. Okay. So this one says the simplest quadratic function is the quadratic parent function. It's similar to the parent function for our linear equation. That means it hasn't been moved up or down or left or right or stretched or made narrower. Okay, so this is the equation for that, y equals x squared. They want us to come up with some values and then plot those points over here. Okay, so I'm going to pick some values for x and just plug them in and see what we get for y so that we have some points. So we know it makes a U shape, right? So I want to pick some x values on this side and some x values on this side. And we want to pick small numbers so it's easy for us to do the math. So I'm going to pick on the left starting at -3. Okay? And then I'll do -2, -1, and 0, which would put me right in the middle. And then I'm going to do the positives for 1, 2, and 3. All right? Okay, so now I'm just going to take these numbers and plug them in for x in the parent function. So if I plug in -3 right there, that would mean -3 squared, which really means -3 times -3, and a negative times a negative is going to give me positive 9. Very good. Okay, same thing for -2. What's -2 squared? Very good. And what's -1 squared? Very good. And what's 0 squared? Good. And 1 squared? And 2 squared? And 3 squared. Okay. So now I'm just going to take these coordinate points, come over here and plot them. So the first coordinate point I'm going to plot is at -3, 9. So I go to -3 and up 9. There's my first one. All right, next one is at -2, 4. The next point is at -1, 1. And then I have a point at 0, 0. And then we've got a point at 1, 1. Another one at 2, 4. And our last one is at 3, 9. Okay, so once we have all those plots pointed, we're going to go in and connect our points. And it should make that U-shaped parabola that we're familiar with. All right. So they ask, where is the vertex here? Very good. And they didn't ask, but would that be a maximum or a minimum? Minimum. Very good, because it goes up from there. Okay. X-intercept. How many times does it touch the x-axis? Just once. At where? Good. Okay. Then they ask for the y-intercept. How many times does it touch the y-axis? Once at. Good. All right, then they want the axis of symmetry. So where I could fold this thing in half and everything match up. Right. Remember we write that as a linear equation of x equals 0. All right, what about domain? Is this thing ever going to stop going left and right? Nope, so we put. Very good. And then lastly, our range. Very good.